Very good morning, friends. Welcome to my YouTube channel. And friends, in today's session, we are going to have the third derivation on the design of keys. Friends, the question for today's session runs like this. Derive an expression for the length of the key L in terms of shaft diameter D, where the shaft and key are of same material and of same strength. So friends, same material means what? The values of stresses will be same. Suppose stress in the shaft and that in the key will be same. And they are of same strength. That is to say, both the shaft and the key will be transmitting the same amount of torque. So finally, if L is the length of the key and D is the shaft diameter, I want an expression of L with the D. That is what is required in this session. Friends, again I have written the front view of a shaft with a key having thickness H, width B, and it will have a length L. So a key is always designated by B into H into L. Suppose for a key is represented by 20 into 14 into 100. 20 will be the width. Second, H will be 14 and L will be the length of the key. Friends, here in this problem, using this torque mt, the shaft is transmitting a torque mt. Let us write down the expression for the torque transmitted by the shaft. So in general, we have mt shaft means the torque transmitted by the shaft. Mt stands for the torque or torsional moment is equal to pi d cube by 16 into eta into tau s. We'll call this as equation number 1. So this equation is derived from the basics, that is mt by j is equal to g theta by L is equal to tau by r, the expression for the torque. So here friends, D stands for the diameter of the shaft, which is 2 times the radius, and tau s stands for the shear stress for the shaft material, and this eta is a term, and this is called as a key weigh factor. So basically we should know what a key weigh factor is. Friends, if you have two shafts, one of diameter D and other also is having the same diameter, both are having the same diameter, but whereas in shaft number 2 you have a key weigh or key slot is made along the length of the key. Then what happens? If this is transmitting torque mt, the torque transmitted by this will be slightly lesser than that because of the removal of the material along the length of the shaft. And generally it is assumed the torque transmitted by the key with the shaft, with the groove or key hole or key slot is around 25% lesser than that of the torque transmitted by the shaft. That is to say, this factor keyway factor eta is taken as 0.75 to zero point 0.8. Friends, now coming to the second, that's the expression for the torque transmitted by the key. In general, friends, you know, the torque transmitted by the key, mt key, in shear is given by the equation B L tau k d by 2. This is the expression. You can number it as 2, and this will give you what is the torque transmitted by the key in shear, because the shear stress we are using. And now the question is, these two, the shaft and the key, are made of the same material and they have the same strength. First of all, let us consider that they have the same strength. In other words, the torque transmitted by the shaft and that of the key, they are same. That is to say, I am going to equate mt of the shaft to empty of the key. That is, torque transmitted by the shaft is equated to torque transmitted by the key. That is, we are going to equate expression 1 and 2. So you will get the value like this: empty of the shaft pi dq by 16 into eta into tau s is equal to that of the key is BL tau k d by 2. Friends, here the shaft and the key are made of the same material. Hence, the value of tau s, the shear stress of the shaft, and that of the key tau k, they get cancelled. And here, one of these d gets cancelled. Here, 2 is here, 16 is here. I will just simplify this and say 5d square by 8, because this is 2 times 8, into that eta is 0.75. The key wave factor I have taken as 0.75 is equal to L into B into L into D. Sorry, D has got cancelled already. So it is pi d square. Friends, if you further simplify, I want an expression in terms of this L and D. So I'll write down B into L is equal to pi d square by 8 multiplied by 0.75, the key wave factor. I am interested in L, which is equal to pi d square by 8 into 0.75 divided by B. I will take to the denominator. Friends, generally, if B is the width, D is the diameter, the value of this B will be 1/4 the shaft dia. I'll write down here B is equal to D by 4. A thumb rule says like this. So with this, I can just put it as D by 4. Friends, if you simplify this, you will get L is equal to 1.178 times D. This is the expression connecting the length of the key with the shaft diameter when they are made of the same material and they are transmitting the same torque. Thank you, friends.